Hello, this will be a quick tour of my 1999 Daewoo Matiz that I've converted to be 100% electric. This has been on the road since May 2011. I've done 10,000 miles in it, and well, aside from the fact that I've got the glove box out at the moment, you can see that it still has seating capacity for 5 people. The Matiz is quite a small car. I deliberately chose it for its size. It's the predecessor to the Chevy Spark, but they're basically the same car. So inside, we'll have a look here. There's a couple extra screens at the moment. Don't know if you can see the clutch pedal's kind of sitting on the floor because there is no clutch in this. And just next to the ignition switch we also have our big red button, which is a battery disconnect. We switch on the ignition here. You'll also see that little light bulb there. That's my controller pre-charge. If we pull out the big red button so that we can get the battery pack connected, and you'll see that's just pre-charging my controller now, getting the capacitors charged up, and then the main contactor clicks in, and now the controller is all ready to go. It takes about 7 seconds for it to pre-charge, and the light bulb just gives you some visual feedback. If there was a problem, say something had shorted out in the controller, the light bulb would stay on. This is the display for the battery management system. You can see it's a 48 cell system. You've got the pack voltage and the highest and lowest cell. Some temperatures of the battery pack. It's winter, you can see they're just slightly above freezing. And over here, this is a readout of information from the controller. I've got it in neutral. We can just blip the throttle a little bit here. You can see the throttle coming up. The temperature on the controller, I've kind of calibrated it for normal operating temperatures, so it's outside. It's showing -10, but I'm more concerned about kind of the 50 to 70 degree range, which is where it's fairly accurate. But there you go. Otherwise, everything's pretty much normal in here. Let's go have a look up under the bonnet. I'll press in my big red button there. That is one of the safety features I've built into this. This little button here is input for the battery management system, so when you're charging the vehicle you can start the charge. There's also some other screens on that with more information. It's just started to snow, so we'll have a look here under the bonnet, or the hood, depending on where you are in the world. Right, you probably can't see it very well in here, but there is a net gain Impulse 9 motor buried down in there, just kind of right underneath. The controller, this is the Paul and Sabrina cheap electric vehicle controller, 144 volt, 500 amp. That's the top of it. It took me a while to figure out that I needed to turn it upside down and put the heat sink up the way so that it dissipates heat better. But at any rate, if you search Google, you will find information on the controller. It's an open source kit. You build it yourself. It doesn't quite have the punch of a Curtis 1231C, but it is much smoother in operation. This is the contactor that closes after the pre-charging is done. There's 2 contactors in the system. Another contactor in the back of the car, the boot or the trunk, which comes on with the ignition. or when you're charging, and this one's only activated when you're driving. At the very back in there, that's actually the disconnect switch, the other end of the big red button. I've extended the button using some plastic plumbing pipes so that I've kept all the wiring in the engine bay without pulling them inside the car. And then you've got your Zivan NG3 charger, and that's been working quite well. No complaints about that. Highly recommend that charger. And this here is the Kelly Controls DC to DC. It's 144 volt to 13.5 volt. So essentially this is my alternator, which keeps my original 12 volt battery. So that's my 12 volts for my lights and my electrics, and it just all charges from that. I've not had to do anything with that in nearly 2 years of driving. It's just the DC to DC keeps the battery charged up. This is a pair of solid-state relays. This is for my heater. I've got a, let's get this wire out of the way, got a 1500 watt electric heating element for the winter. And this is the front battery box, which you can just see kind of the top of it. It extends around the front of the car, and it's effectively 9 cells, this box, although I'll see if I can get a good zoom in here. The cells there, the China high power 40 amp hour cells, and as you can see I've paralleled 3 together for a capacity of 120 amp hours. So it's a 48, essentially a 48 cell system, but in actual fact it's 144 cells grouped together as a 3 parallel 48 series configuration. So that's pretty much everything. Oh, there's for the brakes, we have this. This is a Volkswagen vacuum pump. Let's see if we can get the part number here. 8E0927317B. And I did buy that new from a Volkswagen dealer, but they're used on turbocharged petrol versions of some Volkswagens. Vauxhall's also doing a similar sort of thing on some of their latest cars in the UK. Again, little turbocharged petrol ones. You usually find this auxiliary vacuum pump. And this is simply wired straight to the brake lights, so whenever I step on the brakes, the pump operates, and it's just a vacuum hose straight into the brake servo. And it's crude, but it works very well. And you probably won't be able to see it in here, but all the way down in there, I don't think this is going to come out. Oh, you can just about make it out. That's another solid-state relay, and that controls the power to the charger, which means my battery management system has control over when the charger can actually operate. And if there's any sort of problems or issues, the BMS just turns the charger off. And so there we go. So that's under the bonnet. We'll close that up. If we come around the side, we've got the charging port. You've got to put it where the old petrol cap was. This is a, it's called an AquaSafe Series 185 connector. It's waterproof, it's compact, and I'm quite pleased with this. It's held up very well. There's no discoloration of the terminals, unlike, you know, if I charge with a 13 amp standard British 13 amp plug, they do tend to get a bit warm, but that connector has worked very well and held up quite well, and the waterproof cover is a nice touch. And in the back of the car, you'll see there's more batteries. So this is 1/3 of the batteries in the car, sitting in the space where the spare wheel was. There's another identical sized box underneath the rear seat where the petrol tank was, and then the last third of the batteries is split between two boxes. The one under the bonnet or the hood, which you saw at the front, and a long thin box that runs underneath the central tunnel where the exhaust used to run. That one did cause me a little grief. It sits a bit low, and so I have to watch going over speed bumps. Now, on the other side here, this is another contactor. This one's controlled just simply off the ignition switch or when you are charging. And then on the other side, this is one of the battery management boards. It was supposed to go in a metal enclosure to keep the dust off, but I ended up using that box for another project, and I'm in the process now of replacing these boards with a new design which is much smaller, more compact. These are going to be the connectors, just your standard DB15 connectors for the new board. So at the moment I've got a kind of a Y connector configuration, so I'll be able to run both in parallel. But underneath the battery management board is, you'll see there's an Anderson connector, and it's connect from this battery box down to the box below. And on the other end of the Anderson connector is a big fuse. So that's my main fuse, and this also doubles as a another way to disconnect the battery boxes. So the combination of having two contactors, the big red button, and this removable service plug, we can call it. If you've got a Toyota Prius, you'll know that they have a service plug, and many electric vehicles have a service plug which allows you to disable or disconnect the battery pack. And it's the same idea here. By pulling that Anderson connector out with the fuse, pulling that Anderson connector out with the fuse, pushing in the big red button, and the ignition switched off. That's all four of my battery boxes isolated, completely isolated from each other. So instead of having, 150, 160 volts, I've got two 50 volt and two 25 volt boxes. So that is pretty much it. Quick tour. Performance-wise, it will do 70 miles per hour, no problem. It should do 85 miles per hour. I've not tried it because, well, speed limits around here are not that fast, and there really isn't much need. Going that fast does suck the capacity out of the battery. But it's happily 50 to 60 miles per hour is very capable. Maximum range I've had out of this is about 60 miles. I should have more range than that. I've got a weak cell that has been in the pack since I've started, but it's one of the ones underneath, so maybe this spring or summer I'll swap it out and get some more range. But it is perfectly adequate for my daily commuting, and drives basically like a normal car. And quite often I'll give people rides in the car, and it'll take them a little while to think, something's not quite right. Is this electric? It's too quiet. But there you go. So that's my little Daewoo Matiz. Slightly dirty because I didn't get a chance to clean it, but there you go. That's all for now.